In this series, we are building a production grade task management application. And in the previous video, we finished with our database migrations and our models to map our database tables to our Go data structures, and also all the DTOs, basically data transfer objects, all the data that we are going to receive from the client, and our outputs, all the data type that we are going to send the client to. And with that, we can move on to our repository methods, which is basically going to deal with writing our database queries. After that, we can move on to our service layer, which will integrate different repository methods to perform some business logic. And in the end, we'll finish our handler logic, which is going to deal with all the HTTP semantics. And after that, we'll move on to our routes, defining all the endpoints for our handlers. And with that, we'll be done with our to-do module from the backend side. And we'll also define all the Zod schemas and the OpenAPI contracts so that we can test our APIs in a interactive API testing platform, which is Scalar. All right. So let's get started with the repository methods. So the first thing, I'll go inside the repository folder and create a new file called todo, and this will be our to-do repository. And this is what the structure of each time we define a new repository module is going to be. Obviously, the first thing that we need to do is define the package name, which is going to be repository, because that's the name of our folder. After that, we need to define a new struct for our to-do repository. This is going to be to repository, is going to be a struct, and inside that we'll embed our server instance. And inside our server, since we are keeping all our database connections, our logger, our job service, our config, so embedding server inside to-do repository is going to give us access to all that, so that we don't have to do any kind of global import, anything like that. And this will be a pointer to server.server. Right? And after this, we'll need a initialization method. We'll call that new to do repository. And this is going to take an instance of our server, since we are following the dependency injection pattern server, and it is going to return an instance of to do repository. This is going to be a function. And after this, we'll just return an initialized to do repository, which is going to take the server that was passed on, and it is going to embed that and return a new struct. This is how we are going to start with every time we begin with a new repository module. And after we do this, we have to go to our repository struct, which is going to contain all our repositories, so that can be passed around to different modules like services. So here we'll write to do, and this will contain an instance of our to do repository. And of course, to initialize all the repositories, we have to pass them one by one. So what to do, we'll take the new function, which is new to do repository, and we'll pass the instance of the server, which is S in this case, right? And a comma. And now using this repository struct, we can pass around our repositories into multiple modules. Now coming back to our to-do repository, the first function that we're going to start with is create a to-do. That is our first endpoint. If we go to the DTO, here the first one is create to-do payload, and this is the data that we are expecting. And that's the first method that we'll create for our repository. And this is what the function signature is going to look like. This is a receiver method on top of our to-do repository struct. And in the first parameter, we are taking a context, so that from the parent, wherever we initialize a new context, which in this case comes from our echo instance, since we are using the echo framework. Echo gives us a new context every time a new request comes in. So we'll be passing around that context from handler to service to repositories to our database queries, so that if a request is cancelled midway, then we can also cancel our database queries, and we don't waste any of our computing resources. So you'll see in most of our repository methods, the first parameter is going to be a context. Then we are taking the user ID. Now the user ID comes from the token that the front end is going to pass. We are using clerk for our authentication. So from that token, our backend authentication middleware, which is here, auth middleware, if you check here, we are trying to parse our token and do some authentication checks. And finally, if everything is successful, we are embedding the value of the user ID inside our context. We are also embedding the user role and the permissions. Now, going back, in our service layer, we are going to extract the user ID from the context, and we are going to pass that into our repository method, so that when we create a new to-do, we can pass which is the user who created this particular to-do, instead of depending on the front end to pass the ID of the user, which is not a good pattern for security, right? Anyone can pass any other user's ID, and that to do will be assigned to that user. So that's the reason we are going to extract our user ID from the auth token instead of depending on the client to pass the ID of the user. And in the last parameter, we are taking the payload instance, which is the instance of the DTO that we created in the last video. And this is the type of that. We have title, description, priority, due date, parent to do ID, category ID, and metadata. And in return, we are returning an instance of the to-do, a pointer to that, and an optional error. If any error occurs, in the first one, we'll be returning nil, and in the error, we'll be returning a value of an error. But if there are no errors, then we'll be returning an instance of the to-do, and the error will be nil. Now that we have our function signature, we can jump into writing the database query. And this is what the database query is going to look like. This is a very simple SQL statement. If you are not familiar with SQL, then you should go ahead and brush up on your knowledge a little bit. We're not doing too much of advanced stuff, but these are the basic SQL statements which you should be familiar with if you are going to work with backends. Now, this is a basic insert statement. We are saying insert into this to-dos table, and we are trying to insert these fields: user ID, title, description, priority, due date, parent to do ID, category ID, and metadata. Basically, all the data that we are expecting from our DTO, we are inserting into a new row in our to-dos table. And then in our values, we are adding all these name parameters. Now, Postgres, if you are working with any of the Postgres driver, then most of the drivers provide this feature called positional parameters. And it is advisable that whenever you are constructing a dynamic query, the way that we are constructing here, right? This is a dynamic query because we don't know the value of the user ID at this point. We are just including a placeholder here, and we'll take the value of the user ID from here and we'll insert that into this statement where before executing. And if you wanted, what we could have done, we could have also made this as a string template, and we could have string concatenated all these values, which is a very big security threat. If you are familiar with this threat called SQL injection, then string concatenation while or before executing your database queries is one of the biggest reasons for SQL injection attacks. So never do that. Always try to use positional parameters. Now, the driver that we are using, which is, it offers both kinds of parameters. One is positional parameters, and the second one is named parameters. With positional parameters, what you have to do, you have to write these like this: $1, then $2, then $3, and then you have to pass all the values of the parameters in that order, which in my opinion is a little verbose and a little error prone if you got the sequence wrong. I like the name parameters more because it is pretty clear what are the parameters that we are expecting, and the order does not really matter. And the way we pass the values, that is also more intuitive than passing in a particular order, right? And this is our final SQL statement. Now that we have our statement, we have to do a little check, which is if the user has not passed the priority. Because if you check our data type, the DTO, the priority is an optional field. So if the user has not passed the value of the priority, we want to set a default value for that. We could have set it in our DTO also, but we can set it here also. For that, what you're doing, we are creating a new variable with the value of priority medium, this particular string medium. But since we are following this enum pattern, it's a good practice to use those enums instead of the hard-coded strings, so that in the future, if you want to change the value of a particular string, then you can change in one place and it will be reflected everywhere. We create a new variable with the value priority medium if the user has passed a value of priority, then we assign that to priority. Otherwise, our default value is the priority medium. Now here you can see that since we have used pointer types for optional fields in our DTO, here we can check safely that whether the user has passed a particular value for this field or not. We don't have to worry about the zero values of the fields of the struct. Now that we have all the values for all our parameters, we can finally execute this query. And this is how we execute using PGX. We call this function called query. Now, where does it come from? Inside our repository instance, we have embedded our server. If you check here, we have embedded our server. And server in turn contains a lot of other services. And one of those is the DB service. And that's what we are doing here. We are trying to access the server instance from our repository instance, our to-do repository instance. From there, we are taking out the DB instance. Inside DB, we also have a pool instance, which is the connection pool that we are using. And finally, we are calling this particular function called query. And this takes a couple of arguments. The first one is, of course, the context that we got from our parent. Second, the statement, that we built here, the insert statement. And finally, all the arguments that we want to pass into our query, which basically means that the value of all these parameters. We are saying that these are the placeholders that we are declaring, but when we execute our database query, we are saying to our driver that we will provide the values of all these parameters. And that's exactly what we are doing here. And one thing to keep in mind is this structure and this structure has to match. You cannot do snake case here and do camel case here because this is a named parameter, so the name has to match. Same way for title, description, priority, all of the parameters that we had declared above, we have passed the value for those. Most of them are coming from our payload, the payload that the user has passed, but priority we built here to handle a default case, and user ID is coming from our service layer, right? This is all the data that we need to create our to-do, and we are executing at this line. After execution, we get potentially two values. One is the result of this query, all the rows that were returned after the query was executed. Since we are doing return star, this means that after a new row is added into our table, return us the new row so that we can send the values of that new row to our client. So this new row entry will be stored inside rows. And the error, if there was any kind of error while we are executing this insert statement, then this rows will ignore and will check what is the error and will handle accordingly and will return from that point. So that's exactly what we are going to do in the next line. In the next line, we are checking that if the error is not nil, if there is some issue while we are executing this particular database query, then we want to return from this point. And what we are returning for the to-do instance, we are returning nil because of course the database query was errored out. So we don't have an entry for the newly created row. And in the error, you are wrapping the original error that we got from here using fmt.errorf, and using the %w value, we can embed an original error inside the wrapped error. And we are providing a user-friendly message that failed to execute create to-do query for user ID this and title this, and passing the value of user ID and title, and finally the original error. Right? This is the pattern that we use for wrapping an original error and returning a wrapped error to our caller, basically the parent who called this repository method. If the error is nil, which means that our database query was successful, then we go ahead and deserialize the newly created row into a Go struct, right? So that we can return that to our client. And at this point, if you are already familiar with how to perform database queries, etc. in Go, if you've already worked with the backend in Go, there is an existing pattern which is basically to do something like defer rows dot close, and after that you go through rows next and you loop through all the rows and you deserialize whatever value you are getting into your own struct by initializing the struct yourself. There's a lot of verbose code with that workflow, but we are using PGX, and PGX provides some nice primitives, nice workflows, so that we can get rid of most of the boilerplate code that comes with database queries while working with Go. We can perform all those workflows with one line, which is this. And this is the important function here, which is collect one row. And this is provided to us by PGX. And what this function does, it automatically closes our rows. So we don't have to manually do defer rows.close. And then it takes our struct, whatever struct where we want to deserialize our newly created row into, and it passes that into this generic type, which is row to struct by name. And it also takes our rows, the return results. And finally, it returns us a newly created struct with the deserialized value of all the rows that were returned. But in this case, since we are only expecting one row, that's why we have used the function collect one row. There is also a function called collect rows that we'll use when we are dealing with array values, when we are expecting multiple rows. Right? Finally, if you hover over this, we have a to-do struct, which is something that we want to return to our client. But again, at this point also, we can get an error. So we have to handle that also. In the next line, we do if error is not nil, then we return an empty instance of todo.todo, which is basically nil, and a wrapped error. And we are saying that failed to collect row from table to-dos for user ID this and title this, and we wrap the original error. Finally, if there are no errors and we have our to-do item, then we just return the pointer to-do item, and for error, we return nil. Since we have declared in the signature that we are returning the pointer, that's why we have to return the address of the newly created to-do struct. And that is our whole create to-do repository method. Moving on to our next method, which is going to be get to-do by ID. And this is for when a user wants to fetch all the details of a single to-do. They can pass the ID of that to-do in the path parameter, and they can fetch the details using this particular API. But for this API, we cannot just send them the value of the to-do in this format, which is the to-do struct. And if we go inside to-do struct, it has all the fields, but when a user wants to fetch all the details of a particular to-do, they also want extra information like what is the actual category of that particular to-do. Now here, if you notice, we are storing the ID of the category. But if we just send the ID of the category while we are sending the information of the to-do, then there is no way for the client to show to the user that what is the name of the category or what is the color of the category when it was created. All that information which is stored in the categories table for this particular category ID primary key. So when we send the information of a to-do, the complete information, we have to take into account that what are the extra pieces of information that a client might need for this particular to-do. That's why we have to define a new struct which is going to embed the existing to-do struct, but it is going to add some extra fields for sending those extra pieces of information. So let's do that first. We'll do type and we'll name it as populated, and this is going to be a struct. And the first thing we do, we embed the existing to-do struct so that we have all these fields, and we'll add more on top of these existing ones. The first thing, as I said, is going to be the category information. And this is going to be a pointer to our existing category model, is category.category. And we'll also need the struct tags for this. For example, sending the serialized value to our front end and reading data from our database. That's why we add these tags. After category, we also need to send if we have a to-do and it has a couple of child to-dos or sub to-dos, whatever that you're calling in your client. Then for a particular to-do, we also want to send an array of all the sub to-dos for that particular parent to-do. And that's the next thing that we are going to add here, is going to be children. And inside children, we are passing the type as the slice of to-dos. We don't have to populate the sub to-dos. The parent to-do populated one is enough. So for the child to-dos, we are sending the unit value of the to-do without any populatory information. And similarly, all the struct tags. We also need to send all the comments that are created for that particular to-do. And this is how we do that. We pass a slice of the model comment.comment. And later on, when we have created our attachments module, we'll come back and we'll add attachments here. But for now, we can leave it and go back to our repository method and finish implementing that. So that type error is gone now. We can implement get to do by ID database method. This query is going to look a little complicated, so just bear with me. I'll explain every single line, and this is the final database query that we are going to need. So let's go through this query and understand what's exactly we are doing here. So we can start from here, which is a more intuitive starting point as compared to the select statement, right? The first thing we're doing from to-dos table. So we are executing a select statement, and the table that you want to extract rows from is from to-dos. So that's where we start. From the table to-dos, we are giving it an alias so that when we are doing join operations, we don't have to repeatedly write to-dos again and again. We can just write T. And we are joining the table to-dos, and we are performing a left join with the table to-do categories. And the condition is inside the table to-do categories, the ID of that should match with the category ID of our to-dos table. So basically, we are performing a left join with our categories table so that for a particular to-do, we can fetch what is the corresponding category information for that to-do. And the condition is obviously inside our to-dos table, we have a field called category ID, and we are using that ID as a condition for our join so that we can fetch that information from the categories table. Right? And again, we are also adding a condition that the user ID should also match so that one user cannot fetch the information of another user. Similarly, after this join, we are whatever result that we get from this particular join, again, we are performing another left join with the to-dos table. Now, this is a self join because for a single to-do, if it is a parent to-do, then we want to fetch all the child to-dos of that to-do. And for that, we have to perform a self join. And again, we have the same condition. Inside our to-dos table, we have a field called parent to-do ID. And using that, we can fetch all the child to-dos from the same table. Again, the same user ID check that we have for safety reasons. Third, we are again joining with the comments table so that for a single to-do, we can fetch all the comments related to that. All of them pretty much follow the same pattern, so nothing to explain here. And at last, we have this to-do attachments join also, but we'll come back to this after we have our to-do attachments table. For now, we have not created it. We are just finishing our basic modules. So we can just go ahead and remove this, right? That is our from statement. Then comes our where part in our SQL query, where we are saying that the t.id, basically the to-do that we are interested in, the to-do that we want to fetch the information for is placed in this ID named parameter that we are going to pass when we finally execute this database query. And also again, another safety check for our user. And finally, we are grouping by t.id and c.id, basically to-dos.id and categories.id. If you don't do this, we'll get an error that in the select statement, you are performing some aggregate operations. So group by statement has to contain these two fields. Now that we have the bottom part clear, let's go to our select statement so that we understand what is the type of data that we are fetching from all these tables after performing all the joins. Now, the first thing is t.star. So from our to-dos table, we want to fetch all the fields, right? That is the first requirement. And that is the base requirement. We want all the fields of this particular to-dos tables row. Then comes our category information, right? This part. Here what we are doing, since category ID is a optional field inside our to-dos table, that's why we are performing a case statement here. And what we are doing inside, if c.id is not null. So here C basically means the alias for to-do categories. Since we are performing a join here, a left join, if there are no categories for this particular to-do ID using the to-do.category ID field from our to-dos table, then c.id will be null, right? And since c.id is null, will land in the else case and will be returning the value null. If c.id is not null, that's what we are handling here. If c.id is not null, then take whatever row that we are getting for categories, that's the value of C, pass it in the camel function. If you remember in the first migration statement, if you go inside migrations, we created this function called camel, and that's what we are using here. Whatever row we get for category, pass that row into this camel function so that all the fields are in camel case. Then convert that into a JSON. That's what this doing here, to JSON binary. And finally, whatever we get, we name that whole thing as category. Now category can either be a null or a row from the to-do categories table. That's the use of this part. Now moving on, we need the children field. So for children field, we are performing this logic. Now starting here, we have a coalesce. Now in Postgres, coalesce basically is a function using which you can provide some default value. So if this part is null, then an empty array will be returned for the children field. So that is the first thing, coalesce, and then we land here. This is the actual logic. If this is null, then we'll return an empty array. Here what we are doing a JSON aggregation, a JSON binary aggregation, but a JSON aggregation. And what are we aggregating? Here we performed a self join using left join with the to-dos table for collecting all the entries for the children to-dos of a particular to-do using the field parent to-do ID. And here, after we have all the rows, what we're doing, we are passing each row to this camel function so that the fields are formatted as camel case so that we can easily send to our client. Then we are converting that into JSON. Finally, here we have an array at this point. Now we are ordering all the entries of that array using these two rules. The first rule is sort order should be in ascending. We have a field called sort order and it has values like 0, 1, 2, 3, etc. That should be in ascending. And the second parameter is the created at field. That should be also in ascending, right? That's how we are ordering all the entries in our array. Finally, we also have a filter clause here. Before constructing this array, which is a array of child to-dos, we are filtering if the child.id is not null, then only we'll proceed with this part. So if for this particular left join, there are no values, then we'll land here and we'll be filtering out all the null values from this. And finally, we are using JSONB aggregate. So we can collect multiple JSON entries using this function. And then in the children field, we'll have an array of to-dos, either that or an empty array because we are using the coalesce function. That takes care of our children field. Similarly, for the comments field, we are pretty much doing the same logic. After performing a left join with the comments table, we'll have all the comments rows that are associated with a particular to-do, and we are converting that into an array of comments. And we'll do the same thing for attachments, but now that we don't have attachments, let's get rid of this. And that is our whole query. After we have our whole query, the rest of the things are pretty straightforward. Don't have to repeat the same thing, since this will be the common part, which we'll be doing in pretty much all the repository methods. First, we'll call this query method. Either it can be query or query row or exec. The difference is when we are using query, we'll be getting a list of rows that later on we can collect into a particular struct or an array of structs. If we are using either exec or query row, then we won't get rows in return. That is the difference between query, exec, and query row. Again, same, we call this query function. We pass the named parameters, which is the ID of the to-do that we are getting from our payload, from our client. Then the user ID that we are extracting from our context. Then after calling this query function, if there are any errors, we return a wrapped error. If there are no errors, then we use this pgx collect one row to convert whatever row that we got as a result, and we deserialize into a populated to do struct. And finally, we return that struct back to our client. After this, we need to create a utility function, which is going to be used by our service layer to check whether a particular to-do exists in our database or not. We'll see how it gets used later on. But for now, let's just go ahead and declare this so that later on we can use it in our service layer. And this is a pretty simple query, so there is nothing to explain here. We have this function. It takes a context, user ID, and the ID of the to-do, and returns a particular instance of the to-do. And this is a statement, very simple statement. Select star from to-dos, where ID is this and user ID is this. Pass the value of these two parameters using pgx.named arguments. Then if there are any errors, we return from here. Otherwise, we collect the return row into this to-do struct and we return that struct. right? Pretty straightforward. Moving on, the next method that we need is getting a list of all to-dos, which we have already declared the DTO for here, which is basically this. And this is going to be a paginated response. So that's how we have to structure our database query. On top of that, we also have to take into account all these different filters and sort parameters that we are getting in our query parameters. So for this, we'll be dynamically constructing our final database query once we have our base query. The base query is going to look pretty much the same as the get to do by ID query, is getting the information of a single to do. And here we are just doing the same thing, but we are collecting multiple to-dos, right? So the query is going to look pretty much the same, but we have a lot of dynamic parameters to take into account. This is the signature of our get all to-dos function. The name of the function is get to-dos. It is taking the context, the user ID, and the DTO object, which contains all the pagination parameters, filter, sort, and everything. And in return, we are returning a paginated response, which we have defined here in the base model, which is a generic type, which takes the type of the data, and it returns page, limit, total, and total pages. Some of the parameters that we typically use while we are performing pagination. In the second value, a potential error. And as I said, the query is going to look pretty much the same. Here we again have from statement starting with the to-dos table, then we're joining with categories, then a self join with the to-dos table itself, then the comments table, and finally in the select statement we are doing the same thing. First collecting all the fields for the to-dos row, then the category information, the children information, and the comments information. The query is pretty much exactly the same, but the important part is taking into account all the different parameters that might be coming from our front end. Since all the parameters are optional, for each parameter, we have to check the existence of it and then add that into our main database query. So for starting out, we have some base values, which are these user ID, which we are going to pass in the PGX named arguments in our final database query, and the first condition. Now we are dynamically creating a slice of conditions, which will in the end convert into a single string and add to our database query. But for starting out, this is the first condition. The ID of the user should be the same as the current user that has made this particular request. And these two are the base conditions. Now we can go through each value that might be coming from our client for our get to do's DTO. The first thing is status. And here we check if the value of the status is not nil. Since status is a pointer type in our get to do's query DTO, we can check the existence of it by performing a nil check. We are saying that if query.status is not nil, that means the user has passed some value inside the status filter for our get all to do's endpoint. Then we come inside, what we do, we add this condition into our slice of conditions, which is t.status should be the same of the name parameter status. And in the arguments map, we also add the value of that status, which is coming directly from our client. And we can do the same thing for priority and for category ID. The same pattern keeps repeating. Then we can also go ahead and add the remaining filters. If the user has passed a parent to do ID, then we have to add that into our database query. Otherwise, we don't have to think about this parent-children relationship. We can just say that the parent to do is null. Same for due from and due to. If the user wants to get a list of to-dos from this particular date to this particular date, then they can pass these two query parameters, which is due from and due to. And this is how we add the filter in Postgres, which is just a very straightforward greater than equals to or smaller than equals to. Next up, we can add 3 more filters, which is overdue. If the user has passed the value of overdue, which means that give me all the to-dos which are past their due dates. And the condition for that is all the to-dos which are created before this particular timestamp and the status is not completed, which means they are not done yet, they are pending. And same for the completed check. If we want the to-dos which are not completed, then we add this particular filter. If we want the to-dos which are completed, then we add this statement. Then if the user has passed a value in the search query parameter, then we want to only return those to-dos which have a some kind of match with the search value that the client has passed. And for that, we write the query like this. I like basically means that case insensitive like. So it does not matter whether the client has typed uppercase, lowercase. We are just taking the letters into account. We are not taking the case of those letters. Then we are searching by the title of the to-do and the description of the to-do by whatever the client has typed in the search value. And with that, all our optional query parameter handling is finished. We can finally go ahead and construct this final database query, which is simply going to be a string.join. Then we check that if the length of the condition slice is greater than 0, then we construct our final database statement, which is take whatever our base database statement is, which is this that we have written in the first line of the function. We take that and we concatenate using a where clause by joining all the conditions with AND. And since this is a paginated response, we also need to collect information about how many total to-dos are there and the information of the current page and what is the number that we are going to return for this particular page, etc., etc. So we have to add those statements also. The first thing, we want to collect the number of to-dos that match all these particular conditions so that we can return the total number of to-dos in the paginated response. For that, we need to add these statements. We are writing a simple count statement, which is select count star from to-dos t, and we are adding all those conditions that we constructed above by checking all the parameters conditionally. And if there are any errors, we return from here. Otherwise, we proceed. From this point, we also add a group by statement. As I said, in Postgres, if you are performing some kind of aggregations, you need to add a group by statement with the primary keys of those tables that you are aggregating by. Otherwise, you will get an error from your database. That's why we are adding this. Then we are handling the sort. It's basically if the client has passed any requirements for sorting, then we come inside this. Otherwise, by default, we order by the created at and in descending order. So basically, the recently created to-dos will be returned first by default. Otherwise, if the user has passed any requirement for sorting, then we construct the sort requirements accordingly. And finally, we create our pagination parameters by passing limit and offset to our database query. Limit is going to be the same, which is coming from our client, basically how many entries the client needs in a particular page. And the offset we can calculate from this formula, and we pass this as a parameter, a named parameter in our database query. And finally, after we have all this, we can execute our database query. If there are any errors, we return from here. Otherwise, we call the pgx collect rows. As I said, if we only need one row, we can call the function pgx collect one row. If there are multiple rows, we can use pgx collect rows. And we pass the struct type where we want to deserialize all the rows into. And this will be a slice of structs by default, returned to us by pgx. And here we add a check, which is if there are no to-dos with all these conditions, will throw us an error, which is error no rows. And if we let it pass, it will get caught by our global error handler and it will be flagged as a 500, which is internal server error. Even though that is not the case here, it is not really an error if the user does not have any data. And that's the reason if we get pgx no rows error, then we catch the error at this point and we return an empty paginated response. Basically, in the data field, we'll return an empty array and all these fields will be 0 or whatever value that the user has passed in the query. If it is not of the type no rows, then we go ahead and return from this point and return the wrap error. And finally, if everything goes right, we return an instance of the paginated response struct. The data type is going to be populated to do. It is a generic and it is taking a type parameter with this pattern. And finally, in the data, we pass all the to-dos that we collected. Page and limit is going to be the same as what came from the client. The total that we fetched here at this step using query row and scan, and the total pages is going to be this formula. And now that the same patterns are repeating again and again, we can pick up our pace and go ahead and implement all the repository methods quickly without going through every single line for every single method. So the next method that comes is the update to do, and this is what it's going to look like. Again, the same pattern. We have a base statement, which is an update statement for the to-dos table, and here we have created a base string. From this point on, we'll be dynamically constructing our update statement, and finally we'll execute that query depending on what the user has passed. Since this is going to be a patch endpoint, we are not replacing the complete resource. We are just updating all the fields that the user has passed. So these are our base conditions. Then we check if the user has passed the title, then we update the title, description, then we update the description. Then if the user has passed status, here we add an additional check that if the user has passed, the status is completed, then we also set the field completed at for the current timestamp. If the status is not completed, then we set completed at field as null, right? Same thing for priority, due date, parent to do ID, category ID, metadata. Basically, depending on the presence of what the client has passed in the payload, we add those conditionally to our clauses, our update clauses, using which we'll be constructing our final database query. Same thing for category ID, metadata, and in the end, we check that if the user has not passed any update clauses, then we throw an error that you have not passed any fields to update. You have just called this particular endpoint for no reason. If we have some conditions, user has passed some value to be updated, then we just join that using comma, because that's how update statements work. If you want to update multiple fields for a particular row, then this is going to be our filter. The ID is going to be the to-do ID that the user has passed. The user ID is going to be the user ID that we extract from our auth token. Then we return star, which basically means after we update the particular row, we want to get the value of the updated row so that we can return to the user. Then comes our basic repeated error handling and deserialization and returning our final updated to do. Next up, we have our delete to do method, which again takes the context, user ID and to do ID, and is a very basic delete statement. We want to delete all the rows from the to-dos table where the ID is this and the user ID is this. And here we use the method exec because we are not expecting any kind of deserialization. We are not expecting any kind of rows since the rows are deleted. That's why we are using exec here. Mostly in case of delete statements, we'll be going with the exec method. We pass the to-do ID and the user ID using the named arguments. We check for error here. Finally, we reach here, and here we add a check that if the affected rows, after we perform this exec statement, inside result will be getting this function called rows affected, calling which will get the number of rows that got deleted because of this statement. If that number is 0, which means that these two conditions that the user has passed, they do not match any of the entries in our table, which means that we can send an error, a not found error, that this particular to-do that you're trying to delete does not exist in our database. And finally, we return nil. Since it is a delete endpoint, we do not return any kind of value. We do not return the deleted to-do. We just return a 204 status code, which says that there is no content, but the operation that you're trying to do is successful. All right. The next method in line is get to do stats. Now, this is the API that we are going to use for our dashboard for showing how many to-dos do we have, the total, how many are in draft, how many are in active, how many are completed, or how many are in archived, and how many are overdue. So for this, we'll need to add a struct, which we have not added, which we can in our to-do model. So let's just go inside the to-do model using this, and below here we can add a struct. This is going to be a very basic struct with all integer types, which is total number of to-dos, total that are in draft, total active, total completed, archived, and overdue. And these are the JSON tags that we need for sending to our client. Now going back to our repository method, if we take a look at the database query, this is the only important part because this part will keep repeating in every single repository method. So we don't need to explain this again and again. But the database query is also pretty straightforward. We are taking entries from the to-dos table where user ID is this. That is our base condition. And what are the things that we are selecting? First, how many to-dos there are, which is the count star, the total number of to-dos. Then we have different count statements, as you can see. And inside count, we are basically checking how many are in status draft, how many are in status active, completed, archived, and how many are in overdue. Then finally, we run this query by passing the named arguments and collect whatever information that we get into this to-do stat struct that we just created inside to-do model. And with that, we have all our repository methods that we need for our basic to-dos module. That takes care of our to-do repository. We have an error here, which is for the Google. Next, we can go ahead and implement our category repository and our comment repository, which are going to follow the same pattern. So I am going to skip explaining a lot of details so that we can move on to more interesting parts, which is we also have file upload support. We also have background job processing and adding cron processes, a lot of interesting stuff. So we won't waste a lot of time explaining database queries. So we create a new file called comment.go, which is going to be our comment repository. The structure is going to be same. The package will be repository. Then we have a struct, which is comment repository, and an initialization function for initializing a new comment repository. Then we come to repositories struct. We add support for comment here. And this is going to be an instance of comment repository. And to initialize that, we also need to pass here. It's going to be new comment repository, and we pass the instance of the server. That takes care of our embedding repository struct. Then we go back and implement all the methods of our comment repository. The first method that we need is, of course, to create a new comment. For that, we add a method which is called add comment. Takes a context, user ID, the name of the to-do, the ID of the to-do where we want to attach this comment to, because every comment is attached to a particular to-do. They have a one-to-many relationship. And finally, the payload for comment, which has the content inside it. Right? And this is the database query, which is a very simple insert statement. We insert into this table to-do comments. These are the three fields that we're inserting: the ID of the to-do, the user ID who created this comment, then the content of this comment. And these are the name parameters. And we are returning whatever row, the new row that was created because of this insert statement. Then we execute this particular query by passing all the named arguments. We handle the error here. Otherwise, if there are no errors, then we get the new comment deserialized into this struct and we return this finally created comment. Similarly, we have a repository method for getting all the comments for a single to-do, and it takes a context, a user ID, the ID of the to-do, and it returns a slice of the comment struct, and of course an optional error. And the database query is pretty straightforward. Select star from to-do comments where the ID of the to-do is this and the user ID who created the comment is this, and order all those comments in the ascending order of the created at. Basically in the order that the comments were created, instead of showing the recent comments first, which will be in the descending order, but in the ascending order, the oldest comments will be shown first. Then we execute the query, handle the error, then deserialize it into the comment struct using collect rows function and return that. Then we have the get comment by ID function, which returns the information of a single comment by taking the user ID and the comment ID and returning a pointer to the comment struct. This is the query, select star from to-do comments. The comment ID is this and the user ID is this. Then execute, handle the error, deserialize, then handle any error if here, otherwise return the comment. So you can notice that the same pattern keeps repeating, but the only thing that changes mostly is this part, the database query, and if it is a update statement or a get statement of an array type, basically a paginated response or get all type of statement, then we might have to handle all the optional query parameters, or in the update statement, all the optional payload types of the request body. Otherwise, it's mostly the same. We are repeating the same pattern again, but conditionally, we either use collect one row or collect rows. All right. Moving on, we have the update comment method here, which is update the table to do comments. In case of a comment, the only field that we can update is of course the content of the comment. That's why we are updating the content here. And this part we don't really need because we already are adding the triggers so that it will automatically update this field, updated at field, every time we change something. That's why we don't need to add this here, and we can simplify the query a little bit. Then we have the where conditions and the same error handling and deserializing step. And finally, we have the method for deleting a single comment, which is delete from the comments table, where ID of the comment is this and user ID is this, and pass the arguments here. If rows affected is 0, then we return an error that comment not found, because we cannot find a comment which we can delete which matches these two conditions. With that, we are done with our comment repository and our final repository, which is the category repository. So let's go ahead, create a new file called category, the same pattern. Package is going to be repository, and we'll need a struct and a initialization function for that struct, which is going to be this category repository and new category repository. And we of course have to add that here. It's going to call it as category pointer to category repository. And here, of course, we have to provide the initialization function, this new category repository, and pass the instance of the server. Now we can go ahead and implement all the methods of the category repository. Since the same patterns are repeating here, I'll just go ahead and paste all the methods, and we can take a very high level overlook, but we should not waste more time explaining the same patterns again and again. So starting from here, the first method that we have is create a single category. Again, this is a insert statement. These are all the values that we are taking into account, and we execute the query, return the deserialized struct. Same way, to get a single category by the ID of it, this is the statement we run, select star from to-do categories, where ID is this and user ID is this. Next up, get categories. Again, this is a get method, and we are returning an array of categories. That's why we are returning a paginated response, because there can be hundreds and thousands of categories, and we don't want to read all the categories at once and return all of them in a single array. We want to paginate that. Okay? We are returning a paginated response. This is our base statement. We select star from to-do categories, and the user ID should be this. After that, we are taking into account some query parameters. For example, if the user is passing something in the search parameter, then we are searching by that value, which is a case insensitive search of the value that the user has typed. Then we are handling the sort. By default, we are sorting by name in the order of ascending. Otherwise, if the user has passed something, we take that into account. And finally, these are all our pagination parameters. After we have this, we execute our query and collect the rows here in the categories table. Then, since this is a paginated response, we also need to collect how many total values that we have for these conditions. That's why we need to run this statement, which is a count statement, which runs for all the conditions, which basically in this case is only for the search condition. Then finally, we collect the total value in this integer type variable and return a paginated response from here. Also, I forgot to add one more error check here, which is this. When we are collecting the rows, if the error is of pgx no rows, then we have to return an empty array instead of raising a 500 internal server error. And finally, we return the paginated response of all the categories. Next up, we have an update category method, where we take the payload and we dynamically construct the update statement. This is our base statement, is update to do categories table. Then if name is present, we add that to the slice of clauses. Color, then we add that. Description, we add that. Finally, we check if there are no conditions. The user has passed 0 update conditions. Then we throw an error that there are no fields to update here. Finally, we join all the update statements using strings.join with a comma separator and add the rest of the database query statement. ID of the category should be this, user ID should be this, and we want to return the updated row. Then we execute the row here and collect the updated row here and return it. And finally, we have our delete category method, where we are just deleting the particular category that the client has passed the ID of. If we cannot find something with that condition, we just throw an error that category not found. And with that, we are done with all the repositories that we need for this particular module, this particular video. Now we can move on to our service layer, which is going to call all our repository methods. And then we'll move on to handlers, routes, sort schema, and OpenAPI contracts. So for the service, let's open this folder and create a new file called todo.go. The package name will be service, and this is how we are going to structure all our services. Now, service methods are pretty straightforward, since the complicated part usually lives in the repository layer, because you have to deal with database queries and constructing dynamic query statements and dealing with transactions and different types of errors, etc. But in all the layers that come on top of repository layer, there we don't really have that much heavy logic, because it's mostly orchestrating all the repository methods and adding a little bit of business logic depending on our requirements. So we can quickly finish the service methods and the handle methods for this module. The first one is the create to-do API. So let's create a method for the create to-do endpoint. This is what it's going to look like. Should be before, right? We have a method called create to do on which is a receiver method on top of to do service. Now it again takes echo.context, user ID, and payload from our handler, right? Yeah, the first point of contact is of course our handler, and it's taking all these values from our handler and returning an instance of the to do, which we are getting from our repository layer. Now the first thing that we are doing is we are extracting the logger that we had stored in our middleware. So if you have watched the boilerplate video where we create a middleware, which is enhanced context middleware, there we create a new relic logger and we store it inside our context, so that in all the downstream layers, we can extract that particular logger and add more context to it, so that all the logs are connected with each other. So if you want to take a look, we can go here, and this is the middleware, enhanced context. And if we come to this line, this is where we are storing the logger inside our context. And we have also created a utility function so that it can take a context and it can use the logger key, and it will return us the enhanced logger, so that we don't have to write all this logic repeatedly. And that's what we are using in our service layer. We come back. In the first line, we are extracting the logger so that we can enhance it, so that we can add more logs to it and connect all of them with one stream. First, we'll have to do a couple of validations. The first one is if the client has passed parent to do ID, which means it is a parent-child relationship that the client wants to establish. Then the first thing that we do, we call this check to do exists repository method that we just created. And using this, we check if the parent to do ID that the client has passed, that to do exists or not. If that does not exist, then we return here, and the client will get a to do not found error in the form of bad request error, which is 400. Next, we are checking another thing, which is if this particular to do that we just retrieved using this check to do exists method, because our requirement is all the to dos which already have a parent, which means that they are already sub to dos or subtasks, and that means they cannot themselves have more subtasks. That is one of our business requirements, and that's what we are checking here. If the to do that we fetched here, that the client wants to assign as a parent to do, if that to do is already a subtask, then we want to throw an error that this is not allowed. But before that, we have to declare this method. So we can go to the to do model, and down here we can declare two receiver methods, which we can use in our service layer to make it more readable. And these are those two. First one is overdue. For a task or a to do to be considered as overdue, this condition should be true. A due date should exist for that task, and that due date should come before the current time, the time when we are checking the overdue or not. And then the last one is it should not be completed. If all these conditions are true, then it is overdue. Similarly, this function, which is can have children, this basically checks that this parent to do ID is nil or not. If it is nil, then it is a subtask which is not already part of a parent, which means it can have children. But if it is not nil, then that means that it is already a subtask and it cannot have children anymore. And now we can use that here in our service layer validation. Next, moving on, if category ID is passed, then we try to fetch that category. If that category does not exist, then we return an error here. Then finally, after all the service layer validations, we go ahead and call our create to do repository method. We pass the request context by converting the echo context to request context, pass the user ID, which we get from our handler layer. We also pass the payload. If there is some error which we get from our repository layer, then we just return that error and we just log it once. And finally, if the to-do is successfully created, we add a comprehensive log here, which will be useful to us when we are exploring our New Relic dashboard. This is part of our whole logging, monitoring, and observability setup. And this is an extensive log. We are seeing that an event with the name to-do created happened. The ID of the to-do is this, the title is this, and the category ID is this. This is the priority, and the message is to-do created successfully. And when we are exploring our logs, we can check this to have a better idea about our business metrics. Great. That's all about create to do endpoint. Moving on, we can add two more methods. The first one is get to do by ID to fetch the information of a single to do or a single task. And the return type is, of course, the populated to do that we just created in our repository layer. Again, the first thing that we do is we extract our logger from our context using this utility function. Then we call our repository function. If there are any errors, we return here. Otherwise, we return the to-do that we fetched. Pretty simple. And same for the get to-dos endpoint. We extract the logger, call the repository method, and return the result. Next up, we have our update to-do endpoint, which basically validates the same kind of parameters that we validated in our create to-do API. So starting with, we extract our middleware. Then we check if parent to-do ID is passed. Then we try to fetch that particular to-do which the client wants to make as parent. If there are any errors, we return there. Then we check if the ID of the to-do which the client wants to update and the ID of the parent to-do which the client wants to assign the parent to. If they are the same, then we throw an error, which is a to-do cannot be its own parent. Even if you don't do it here, we are already checking this in our database layer. So if you go to our migrations, which is this one, here we have added a constraint, which is an ID of to-do cannot be the same as the parent to-do ID. But since we have already fetched the parent to-do ID, we are just adding a basic validation so that we can catch it early. Again, we are checking the same condition if this particular parent to-do can have children or not, otherwise throwing error. We are also adding a couple of debug messages in case we are facing some kind of issue and we are debugging. Then using this trail of debug messages, we can get a better context. Because of this debug log level, our production logging instance will not have all these debugging messages. But in development, we can enable it and see all these debugging messages. Same way, if category ID is passed, if the client wants to update a particular to-do's category ID, then we again try to fetch that category, return any error, and log a debug message. And finally, we call our repository method for updating our to-do, and we log the business metric that a to-do has been successfully updated. These are the last two methods. The first one is delete to-do, straightforward, get the middleware, call the repository method, return any error, otherwise log the business metrics. Same way, get to-do statistics, get the middleware, call the repository method, then return the results. And with that, we are done with our to-do service. Then let's also finish comment service and our category service so that we can move on to our handler layers. Let's create a file called comment.go. Again, the package will be, of course, service. Then we'll have a struct called comment service and an initializer function for that particular struct. And this is what it's going to look like. We have a struct called comment service. It has embedded a few fields, which is an instance of our server, which contains our DB instance, our logger, our configs, etc. Then a comment repository instance and a to-do repository instance for calling different methods of these two repositories. Then take all these instances from our caller and return a initialized comment service. And the same way we can go ahead and implement all the methods of our comment service, which pretty much follows the same pattern. There is nothing new here, but still we'll go through it once. The first method is add comment. We are getting the context, user ID, to-do ID, payload from the handler layer and returning an instance of a comment. First thing, we take out the logger from our middleware. We check if this particular to-do exists or not, for which we are trying to add a comment. Otherwise, we return early by throwing an error. Then we call our repository method for adding a comment. Then we log a business metric that a new comment has been added for this particular to-do. Then to fetch all the comments of a particular to-do ID, this is the method that you use. Take out the logger, call the repository method to check if this particular to-do exists or not. Otherwise, call the repository method for fetching all the comments of a particular to-do and return the results. Similarly, for update comment API endpoint, take out the middleware, try to fetch the existing comment before we try to update it so that we make sure this particular comment exists or not. Otherwise, we throw an error that comment not found. If it exists, we go ahead and update that particular comment by calling the repository method. And finally, we log the business metrics. Now, one thing that I want to mention is these logging business metrics and logging the errors, etc., these are not hard and fast rules, but it depends on what are your priorities, what are the metrics that you want to log, what are the metrics that are of priority to you. And depending on your requirements, you can modify these things, whether you want to log it or not. But since this is a generic project and one of the first projects using the boilerplate, I just want to go ahead and add as many practices as possible, and I'll leave the rest to you, and you can take your call that whether you want to keep these logs or remove it and make it as lean as possible. With that, moving on, we have the delete comment method where we take out the logger, check the comment exists or not, then call the delete comment repository method and log the business metrics and return nil. Because it is a delete method, we don't return any response, only 204, no content. Then finally, there is an error here. Let's see. Right. Finally, we have our category service. Category dot. By now, you already know the drill, so I won't explain it, which is package service, then creating a struct, initializing the struct, then adding all the methods by calling the repository methods. We have create category, where we are doing the same pattern. Take out the logger, call the repository method, then log the business metrics. Same here. Take out the logger, call the repository method, then return the result. Now, since this is a get endpoint, we are not logging any business metrics, but mostly when it is some kind of a create or update or delete kind of activity, then we try to log that metrics as our business metrics to keep a track. Similarly, we have other methods where we are following the same pattern. Great. Now, if we go to our services struct, we can add those here. First one is to do is to service. Next, we have comment, which is an instance of comment service. Next, we have category, which is again an instance of category service. We also have to initialize them here. Category is new category service. And what are the parameters it's expecting? First thing is the server instance, then category repository. That's all. So we can do repos.category, and that will satisfy it because this is of the type repository.category repository. Similarly, we can instantiate the other two services. The first one is comment, and then we have to do. Here we'll have new service, and then we will have new service. And the requirements for new comment service is comment repository and to do repository. So here we'll pass comment and repos dot. And for to do, we have requirement of to do repository and category repository. The first one should be to do repos dot to do, then the category repository. And with that, we have finished our services struct and is ready for consumption of handler layer. Great. Now let's move on to our handler layer, which is pretty straightforward and minimal amount of code as compared to all the other layers. So the first thing we'll do is go to handler, create files. Is the first one is to do.go. The package name, of course, will be handler. And then again, we'll follow the same pattern. We'll define a struct called to do handler. We'll instantiate that struct with the initializer function. And this is what it's going to look like. We have declared a struct called to do handler, and this is where we are instantiating. Another thing to notice here is we have a struct called handler here, and this is coming from our base where you can see here. And this particular struct has a couple of receiver functions. And to initialize this particular struct, we are using this function, which is new handler. So coming back to our handler, we are embedding this so that we can have access to all the receiver functions of this struct. Then we are also embedding the to-do service, since to-do handler is going to call all the methods of the to-do service, and we are passing it and returning a new instance of the to-do handler. Now coming back, we have to define different methods for different endpoints. So this is what the structure is going to look like for pretty much all the handlers. I'll show you one, then we can quickly move on to other ones. This is the handler of create to do API. It takes one parameter, which is echo.context, returns an optional error. And here we are calling this function, which is handle, which we can go inside. This is a handle function, and it does a couple of things. It takes the handler that we want to execute, the status that we want to send, the payload of the request that we want to validate against, and the base handler, right? So if you come back and take a look at this, the first parameter is the handler struct, which we are accessing from h, is the instance of the to do handler, h.handler. Second, this is the logic that we want to execute for this handler, which is take the echo.context for having access to all the context values, then the payload, which we are passing here, which we'll come back to next, and the return type, which is an instance or a pointer to the to do, an optional error. Now, using this utility function called get user ID is coming from our middleware package. We are taking out the user ID from our context. Then we are calling our service method for creating a to do and returning whatever response comes from it. And you are passing the whole thing as an argument to handle as a second argument, right? Then the third is, if this is successful, then what is the status code that you want to return? Or in this case, we want to return 201 because this is a created status. Now, finally, what is the input that we are expecting for this particular handler? What should we validate against? And that's what we are passing here, a initialized instance of our create to do payload, which we had created earlier when we created our DTOs. Right? Now this pattern will keep repeating for every single handler. This is a very nice way for abstracting out all the logic of logging and validating and all the things that happens in a handler layer, and just calling a single function is very easy to read and easy to debug. So let's go ahead and add all the other handlers, which are going to follow pretty much the same pattern. If we go here, I've added all the other handlers, which is get to do by ID, takes a context, then pass the handler struct. This is the logic, is just calling the service method for get to do by ID. The status that we want to return is status OK, which is 200 because this is a get endpoint. Now this is the payload that we want to validate against. Now one thing that you notice is this. What are we doing here? We are using this particular pattern because if we don't, the context that we get here, it forms a closure and two different requests will have some kind of clash when it comes to the validation rules. So by doing it here, every time a new request comes, we are creating a new instance of the context and passing the fresh context instead of passing the context of the earlier request. Same way, we have a handler for get to do's, just calling the service method for get to do's, and the status code is status OK, and this is the input type. Same for update to do, delete to do, and get to do stats. The handler layer is one of the most simplest implementation in the whole code base. So there is nothing to discuss here. So we can go ahead and create the other two handlers. This is the comment handler and category. Comment.go and category. The package name is handler, and this is what the whole handler is going to look like. We're creating a new comment handler struct. This is the initialize function, and this is all the declaration of different API endpoints for different handler methods, which are all following the same pattern. Embed the handler struct, call the service method, define what status code that you want to return if it is a success. Finally, what is the struct that you want to validate against. Same pattern everywhere. Same way for category, package name is handler, and these are all the handler methods. We have create category, get categories, update category, delete category. Right? And with that, we are done with our handler layer. So next is our routes. For routes, we are going to establish one pattern, then we are going to replicate that same thing for all the modules. So let's go to our router, create a new folder. It is called V1 because it's a very good practice to version your routes so that you can provide backward compatibility in case you break something in the future. Inside V1, we'll create a file called todo.go. The package name will be V1, and we'll create a function called register to do routes, and inside that we'll declare all our routes. And this is what it's going to look like. V4. We have created a function called register to do routes. It takes an echo.group instance, to do handler, comment handler, and our middleware. First, we declare a new group with the prefix /todos, so that for each API, we don't have to repeat the same string, which is /todos. Next up, we add the middleware for authentication, which means that the client cannot call any of these API endpoints without being authenticated first. Then we define all the routes for to-dos and for comments for a particular to-do. And after we have this particular function, what we can do, let's create a new file inside this called v1.go. And here we'll merge all the different routes that we are declaring in different files. The package name will of course be v1. Then we'll create a function called register v1 routes, which is going to look something like this. It is going to take an echo.group, all the handlers, all the middlewares, and depending on the requirements, it can pass a particular handler to a particular route and a particular middleware to a particular route. The first thing that we have already declared is the to-do routes. We can call that here. Handlers.to, handlers.comment is showing us error here because we forgot to do one thing, which is adding our handlers to the base handler, which is here. The first thing is to do is going to take an instance of to do handler, then comes the comment handler, then comes the category, and then we can initialize all of them here. Now if you go back to our route, we should not get any errors, and we can successfully register all the routes for to do here. Similarly, let's create two more files for comment and category. Go, and another one is category.comment. Let's package will be v1, and this will be the content, a route for updating the comment and deleting a comment, because the route for getting all the comments for a particular to-do is already here, or adding a comment for a particular to-do is already here. Same way for category, the package will be v1, and this is going to be the function for defining all the routes for categories. And here in the v1.go file, we can register the category routes and our comment routes. Here we'll call these functions. Now if we go to our router.go file, here we can register all the v1 routes that we created. So let's take this into a variable which we are going to call as v1 router, and we'll call the register v1 routes function here, which is from v1 package dot register v1 routes, and inside this we'll pass the v1 router instance and all the handlers, which is edge, and all the middlewares, and that will add all the routes for to-dos, comments, and categories. With this, all the API endpoints are ready to be tested, but in order to test them, we still have to generate all the contracts. So for that, we need to write the Zod schemas first, and then write the contracts, and then we can generate them and test all our APIs. So we have a package called Zod, and inside SRC, we'll create a new folder called, and inside this, a new file for index.ts. And here we'll write all the Zod schemas for our to-do module. Now, the thing to keep in mind is all the schemas that you declare here should be as accurate as possible, and we compare that to our Go structs. So if you don't have knowledge about this TypeScript ecosystem or Zod package, then you want to read up a little on that. Otherwise, the contract that you're going to end up generating is not going to be 100% accurate. The first thing that we'll declare is to-do schema, which is going to look something like this. We are adding two enums for our status and our priority, and one Zod schema for our to-do metadata for tags, reminder, color, and difficulty. Then our final to-do schema, which uses these two enums and the metadata Zod object. Then we'll also need two more schemas for the to-do stats object and populated to-do object, which are going to look something like this. The populated to-do is going to extend the Z to-do schema, and it's going to add 4 more fields. Category, children, comments, and attachments will come later. So for this, we'll need to define category schema and comment schema first. For stats, this will work. So let's create 2 more folders, one for category and a file inside this called index.ts. And this is what the category schema should look like. Then another folder called comment, where we'll keep our Zod schema for comment. And this is our comment schema. If you go back to our to-do ts file, we can import this, and now all the errors are gone. And we have schema for pretty much all the models in our database. Now, I'm not going to explain what each of these lines mean, because that's going to take a lot of time, and it's a pretty basic knowledge if you are coming from TypeScript ecosystem. Then we'll go ahead and write our OpenAPI contract. So inside contracts, the first thing we'll add is todo.ts. Before that, we have to export all the Zod schemas. So if we go here, index.ts, we can export all the created schema like this. Then let's go ahead and create our contracts. Now we are going to use this package called tsrest, and it is a pretty extensive package for a lot of functionalities, but we are going to use the OpenAPI functionality of this package. And before you watch this, I will advise you to take a look at the basics of how OpenAPI schema, etc. work, how you can write a OpenAPI schema in pure YAML or JSON, and a little bit of reading about tsrest. So this is how it's going to work. The first thing that we'll do is initialize a new contract, which is coming from tsrest core. Then we call this function, which is get security metadata. And if we check the content of this function, it basically defines OpenAPI configs for two different kinds of authentication. One is bearer auth, which is used by Clerk authentication middleware. The second one is a service token, if we want to communicate between two different services that we can make use of. For now, we are not using it, but I've added it just for the sake of it. Now going back, we are calling this function and getting a metadata object, which we are going to pass to each of our API endpoints. And this is what our contract is going to look like. If I go here, we are passing this whole object inside a c.router. So we have initialized our contract here, and inside c.router, we are passing all our configs. Now each config has a particular structure. If it is a get endpoint, then we'll have to pass a query object if it exists. Otherwise, we can skip it. If it is something like a post endpoint or a put or patch endpoint, then we'll have to pass a body value. So it has a couple of keys which are going to repeat in every single endpoint, which is one is the summary, where you can describe what this endpoint does. The description is a long format of your summary if you want to add more details. What is the method of this endpoint, which is get. What is the path, which is /todos. Then is the query. Again, we are passing a Zod object here of page, limit, and sort. Again, this should also match exactly with our DTOs, which we have defined in our Go code. Otherwise, you are going to face inconsistencies. Then we have also added all the other parameters that we support in our query. We are getting all these errors because we have not imported it. And to import it, first we have to run our dev server. Otherwise, the import will not work. So here, what you can do, you can run one install, then one dev. And after running one dev and importing all our Zod schemas, these errors should be gone. And after the query, after you have defined the Zod schema for our query, the last thing is responses. If the response code is 200, then what should be the expected response type or the expected response schema? In this case, we are using this function called schema with pagination, which basically takes a particular schema using generics. It returns a object of that particular type inside data and all these other values for total, page, limit, and total pages. And finally, we pass the metadata that we created on top. Going to the next endpoint, it's going to follow the same pattern: summary, path, method, description. What is the body that we are expecting? Again, they should match with our DTO. And what is the response type? And similarly for all the other endpoints that you can explore on your own. I'll push this in the GitHub repository and you can spend some time going through how this works, how Zod works, how tsrest works, etc. Similarly, let's create our other contracts, which is the comment.ts, which is going to look something like this. The same pattern for different endpoints of our comment APIs. And the last one is our category contract, category.ts, which is going to look like this. And after added all the contracts, we can go to index.ts and initialize the contracts here. The first one is to do or to-dos, or let's say, and this will have to do contract. Same for comment, this is comment. Then the last one is category. After we have this final API contract, we can go ahead and generate our OpenAPI.json file. We already have an OpenAPI.json here, but it only has the health endpoint. Now that we have added to-do endpoint, comments endpoint, and category endpoint, we can generate the updated one. For this, we can cd into packages and OpenAPI and run this command, which is called one space gen. After we run this, this particular OpenAPI.json file will be completely updated. And if you want to check the script, it comes from here. You go to package.json. We are running this particular script, which is gen.ts, which exists here, which takes the whole contract and generates an OpenAPI.json file. This script actually places our file OpenAPI.json in two different places. One is inside this package for demonstration purpose, but the actual one inside OpenAPI.json of our backend. We go to backend, static and OpenAPI.json. We'll find it here. Now, if we start our development server for backend, you can go here and go inside apps backend, run task. Then if we go to /8080/docs, let's do a refresh. And then finally, we can see all our endpoints here. We expand these. Everything that we declared using our Zod schema is available here. And all our TS REST contracts are available here. And we can test every single APIs using this whole interface, which is coming from Scalar. So let's test a couple of endpoints so that we know it's working fine. And for that, let's start with get all to-dos. And if we send this, the first thing we get a route not found. And the reason is we forgot to add /API here. So for that, we can go here and in our OpenAPI package, which is here index.ts, the server URL, we can add /API. And let's go ahead and generate the document again. 1/gen. Now coming back here, we do a refresh and try the get all to do's endpoint once more. Now we are getting unauthorized, which is 401, because it is expecting a bearer token auth, but we are not sending it. And since we are using clerk for authentication, we have to generate a clerk token, but we don't have our front end created yet so that we can test our APIs. So we have to go with a different path. First, let's log into our clerk dashboard. We go to dashboard. This is our Tasker app, and we don't have any users created yet. For now, let's create a dummy user. The user can be test.mail.com. And the password, let's say we keep 1, 2, 3, 4, 5, 6, 7, 8. Now, this is not an actual user, so we can compromise a little on the password just for testing purposes. And if we create the user, we're getting an error, of course, that this password has been in online breaches, so we cannot use this. So let's use something else. Let me just type something random. It's test356@98, and the user is created now. After a user is created, we can click on this icon and you can click on impersonate user. Now this is a premium feature. If you are using this on your prod instance, you'll have to pay for it, but since this is development, we are still testing, we can test it without paying. Press OK, and this will redirect us to a page. And in this page, we can retrieve token. But before that, let's create a JWT template. Let me close this. Configure JWT templates. JWT template is a concept in Clerk where you can customize different properties of the token that you get after a successful authentication. Since this is a testing token, we want to increase the time, the lifetime of the token. For now, the name can be something like API test template. You can keep this as blank. Token lifetime, let's say a long value 365,000,000 something. Right, clock skew, this is fine, and let's save it. Token lifetime must be okay. Let's copy the max value, then save it. What's the problem then? Save. All right, now we have a template called API test. Let's go to users now. Let's do the same, impersonate user. Okay, and after we are in this screen, you can open your developer terminal, whatever browser that you use, and run this command in your console, which is await window.clerk.session get token, and in the template you can pass whatever the template that you created, which in our case was something like, what was it? I forgot. API test, of course. Let's clear this API test and hit enter, and this will print your token. You can copy this, come to your testing API testing interface, Scalar. In the authentication method, select bearer auth. In the bearer token, just paste your token and click send. Now we are getting a response, which is an empty response of data with an empty array, page by default 1, limit 20, total pages, because we have not created any to-dos yet. So let's create a to-do and see if this works or not. We'll just add a particular title, which is sample, and click send, and a to-do is created. We got the response here. Now if we run get all to-dos, we should get a paginated response of all the to-dos. If we copy this ID, come to get to-do by ID here, hit send, we should get the information of our to-dos. Since we have not assigned any category yet, the category is coming as null. The children is of course an empty array, and this does not have any comments yet. Now, if we update the to-do, but first let's create a category. Now try get all categories. Of course, it's returning an empty array. If we create a new category, its name is as food, and for color, we can, let's say, hashtag FFFF, and let's create it. We have created a category. So now let's copy the ID of this category so that we can assign it to do. And let's go to update to do, clear everything except for the category ID. And in category ID, let's pass the newly created category ID. And inside the to-do ID, let's copy this one and paste here and hit send. Now the category ID of our to-do is updated. Now if we fetch the information of to-do, in category, we should be getting an object with the category information. If we send here, now we are getting the information of our category, which is name food, color is this, and the other fields. And if we hit get to do statistics, we get some information that we have total 1 to do, and in draft there is 1 and other status of 0. And similarly, let's create a comment. The ID of the to do is this, and the content of the comment, let's say test comment. Let's hit send. The comment is created. Now if we hit the get to do by ID API again, in the comments array, we should be getting the comment, which is test comment, right? There are also other APIs to test, but you get the idea. We have this very useful, very clean interface provided by our own OpenAPI contract, which generates an OpenAPI.json file. And using that, Scalar provides this whole API testing platform that you can use to test your APIs before you even have a front end of your own to test. So that's pretty much all for the first version of our to-do app. In the next video, we are going to add the capability of file uploads using our AWS S3 SDK and Sevala object storage that we created in the first video. And we'll also add cron processes so that every week we can send an overall report of all the to-dos to our user. We can also create a cron process to send an email every day to the user, reminding them of their overdue tasks, etc., etc. So we'll also cover that in the next video. So stay tuned, and that's all for this video.